DES or DES data encryption standard. Data encryption is standard, the most widely used encryption algorithm in the world. For many years, and among many people, secret code making and DES have been synonymously converting to bits. DES or DES works on bits or binary numbers, the OS and 1S common to the digital computers. Each group of 4 bits makes up a hexadecimal or base 16 number. Binary or 0001 is equal to the hexadecimal number or 1. Binary 100 is equal to the hexadecimal number 8, and 101 is equal to the hexadecimal number 9. And we have a 1010 is equal to the hexadecimal number A, and 1111 is equal to the hexadecimal number F. In this table, the plain text here are the hexadecimal and these are the binary of each hexadecimal. Initial permutation. Each of these permutation takes a 64-bit input and permutes them according to a predefined rule. For example, in the initial permutation, the 58-bit in the input becomes the first bit in the output. Similarly, in the final permutation, the first bit in the output becomes the 58-bit in the output. In other words, if the rounds between these two permutations do not exist, the 58-bit entering the initial permutation is the same as the 58-bit leaving the final permutation. Note that the number of output ports is 48, but their value range is only 1 to 32. Some of the inputs go to more than one output. Expand right. Expansion permutation follows a predetermined rule. For each section, input bits 1, 2, 3, and 4 are copied to output bits 2, 3, 4, and 5 respectively. Output bit 1 comes from the bit 4 of the previous section. Output bit 6 comes from bit 1 of the next section.
XOR subkey. After the expansion permutation, DES use the XDR operation on the expanded right section and the round key. Note that the both right section and the key are 48-bit in length. Also note that the round key is used only in this operation. Substitute. DES use 8 S boxes, each with a 6-bit input and 4-bit output. The 48-bit data from the second operation is divided into 8 6-bit chunks, and each chunk is fit into a box. The result of each box is a 4-bit chunks. When these are combined, a result is a 32-bit text. The substitution of each box follow a predetermined rule based on a 4-row by 6-column table T. Permute. The last operation in the DES function is a permutation with a 32-bit input and 32-bit output. For example, the 7-bit of input becomes the second bit of output.
XOR left. After the straight permutation, the key is divided into two 20 bits parts. Each part is shifted left circular shift 1 or 2 bits in round 1, 2, 9, and 16. Shifting is 1 bit in the other round, it is to 2 bits. Rotate halves. Using mixer and swappers, we can create the cipher and reverse cipher, each having 16 rounds. The cipher is used at the encryption site. The reverse cipher is used at the decryption site. The whole idea is to make the cipher and the reverse cipher algorithm similar. DES uses 16 rounds after Pastel cipher. It has been proved that every 8 rounds, the ciphertext is function of every plaintext. bit and every key bit, the ciphertext is thoroughly a random function of plaintext and ciphertext. Extract bits. A very important point we need to remember about that cipher is that the round keys K1 to K16 should be applied into reverse order at the encryption site. Round 1 uses K1 and round 16 uses K16. At the decryption site, round 1 uses K16 and round 16 uses